everyone. So since we didn't finish Friday's examples, in order for you guys to do your ALEKS homework and the ALEKS objectives, I will do them now so you guys know how to do them. Right, but before I start, reminder, I forgot to mention it to you guys, but exam 2, it will be on Friday 10-2. Okay, so next week. Alrighty, so let's start with the examples. So our directions are to graph the function using translation. Another way that this could have been asked is use translations to graph the given functions. Right, so the first graph that we're given is we have first function we're given is h of x equals x minus 1 quantity squared minus 3. Okay, so first of all, so the vertical translation, okay, that's always the easiest one to do. Vertical, I'll call it vertical shift. Okay, vertical shift, remember it is the, right here. Okay, we have f of x plus k. Okay, so it's right here, minus 3. Getting ahead of myself. So something I should actually explain before we start doing the vertical shifts is before we do the vertical and horizontal shifts, we have to understand what is the parent function. The parent function, stripped of everything, okay, we have f of x equals x squared. Okay, and then so we know that we will have the general graph of, like, it's going to look like a U. Okay, if we understand the parent function and the way it looks, okay, mainly just the parent function, the way it looks will just be for graphing. Okay, so if I add anything to this, it will be a vertical shift. In this case, we are adding a negative 3, so we're shifting 3 units down. So 3 units down. Okay, if anything is within this x squared, like x minus a number squared, okay, it's going to be a horizontal shift. So I'm going to call it an h shift. Okay, in this case, okay, remember that the horizontal shift, not intuitive. So I see negative 1, that means I'm going to shift 1. Okay, along the x-axis. So 1 unit to the right. All right. So now that we know the vertical and horizontal shifts, okay, now we just need to know the parent function. So we know the parent function, given just plotting the points, okay, this is for f of x. Right, again, we picked negative 2, negative 1, 0, 1, 2, okay, because the vertex is 0, 0. So this will be 4, 1, 0, 1, 4. Okay, we can do it 2 ways, okay, and I'll show you both. So the first way, what you can do is you can just plot the parent function, so negative 2, 4, negative 1, 1, 0. Okay, you don't necessarily need to graph the shape. Okay, you just need to know the points. Okay, and then you're going to take every point and you're going to do these shifts. So vertical shift, so I'm going to start with the leftmost point. I'm going to go 3 units down and 1 unit to the right. So I'm going to go 1, 2, 3, 1. Okay, conveniently is on the point that the second point I need to look at. Okay, but I'm going to go, so 1, 2, 3, 1. I'm going to look at this vertex and go 1, 2, 3, 1. 1, 2, 3, 1. And then 1, 2, 3, 1. Okay, and then I can graph it this way. Okay, so that's for that is how you can shift given the points. I'm pretty sure on ALEKS what they'll do is, like, they give you any shape of the graph. They give you a point and then they say, okay, like say that this was f of x and they give you h of x and they say shift it. So what you're going to do is you're going to take this point and you're going to shift it however many, you're going to plot that point, and then ALEKS will conveniently graph it for you. Okay, so yeah, that's how you can do it when you're given points. But if you don't, you know, because this looks a little messy, okay, so what we can do is we can just graph it correctly from the very beginning. So what we're going to do now is you still take this table, okay, but you're going to apply the, so V shift, 1 second, V shift, is minus 3, and then h shift plus 1. Okay, so what does that mean? I'm going to put it over here. Okay, the reason why, there's no room right there. So what does it mean to be a vertical shift? We're going to change our y values, and for a horizontal shift, we're going to change our x values. So that's what these tips mean right here. Okay, so for the horizontal, so this is I guess what you could have done instead of vertical shift, just, for less writing, you can call this K, and then you can call this horizontal shift H. Okay, a good way to remember HK, okay, H represent H horizontal, so they're both the same, and then K is the other one, which is vertical. Okay, so what I want to do is we're going to do Y plus K, and we want to do X plus H. Okay. When we do that, so our H is the horizontal shift, remember, so we want to do X plus 1. For the Y, K is negative 3, so we have Y minus 3. What I'm going to do now is I'm going to take these parent functions, okay, so these represent my X and Y, and I'm going to, for all my X's, I'm going to add 1, and for all my Y's, I'm going to subtract 3. So negative 2 plus 1, that is negative 1. Negative 1 plus 1 is 0. 1, 2, 3. Okay. Y minus 3, so 4 minus 3 is 1. 1 minus 3 is negative 2. 0 minus 3 is negative 3. 1 minus 3 is negative 2. And then 4 minus 3 is 1. Okay. So, so these are my points, and you would graph. So, since we already graphed them, this is me just checking. So I have negative 1, 1. That is the point right here. So we got that right. 0, negative 2. That is also right. 1, negative 3. 2, negative 2. 3, 1. Okay, so this just shows you this first way. Okay, no matter how magical it may seem, this is correct. Okay. So yeah, but this is how you would find it using this way. Right? So let's do another example. The next example I am given, I have f of x is equal to x plus the quantity x plus 3 cubed plus 1. Right? So first of all, what is the parent? I'm going to call it p of x just because f of x is taken. So for me, it represents parent right now. Okay, so looking at this, stripping it from everything, it is x cubed. What does x cubed look like? It is that snaky looking thing. Alright, so this is the parent function. This is what it looks like in general. Okay, so getting my x and y's. Okay, if you want, you can look up here. Okay, remember, so for the cube function, we just pick negative 2 through 2. There's nothing special we need to find over here. Okay, and so we'll get negative 8, negative 1, 0, 1, 8. Okay, this is the parent table, if you want to call it that. Okay, this is the table of points that give us our parent function. So this is x cubed. Okay, this was p of x. So now what we're going to do, okay, is, I just keep skipping steps, aren't I? So first thing, you want to discover that, like, you just want to think about the parent graph and the general shape of that graph, okay? And then before you talk about p of x, you should think about the vertical and horizontal shifts. To be honest, it really doesn't matter the order, but just to try to be consistent, I'll do that. So remember, h represents the horizontal shift. So our h is negative 3. Remember, it is not intuitive. It is the opposite. So instead of x plus 3, it is negative 3. Okay. Well, you know what I mean. Like, h is minus 3 because it has x minus h. So this would be x minus a negative 3. Okay. And then our k is equal to 1. Okay, so what does that mean? We want x minus 3 and then y plus 1. Remember, we want x plus h, and then this is y plus k. Right, so now let's take these x values. So negative 2 minus 3, that's negative 5. This is negative 4, negative 3, negative 2, negative 1. Right. For y, so negative 8 plus 1, that's negative 7. Negative 1 plus 1 is 0. This is 1, 0, and, no. Negative 7, 0, 1, 2, 9. Let me grab a graph real fast. It's fine, I'll just keep it right here, because technically we don't need the p of x, because we're not going to plot that. Right? So, again, so I have negative 5, negative 7, negative 4, 0, negative 3, 1, negative, negative 3, 1. Oh man, guys. I told you it was Friday. Negative 5, negative 7. Negative 3, 1. Negative 2, 2. Negative 1, 9. Okay. So, what I'm going to do, so this is like that. Ooh. Okay, and that's our graph. Again, I'm just going to plot this middle point right here, so 0, 0. Okay, and what I'm going to do is I'm going to go down, up 1, up 1 over 3. 1, 2, 3. And that's this point right here. Okay, that's negative 3, 1. And as you can see, it fits. Right? So this is the graph of f of x equals the quantity x plus 3 cubed plus 1. Right? Now, what we're going to do is we're going to do example 3. Okay, example 3, we are given g of x is equal to the square root of x minus 3 plus 2. Right? Again, what is h? H is 3, k is 2. Right? Because it has x minus 3, so this is going to be positive 3. And then what is my parent graph? Again, I'll call it f of x. My parent graph in this case is the square root of x. When it's stripped from everything, the most basic one is the square root of x. Okay, the square root of x, it looks like this. Okay. So again, let's pick the points. So for f of x, what does the parent table look like? Pretty sure they start at 0. What? 0, 1, 4, 9, 16. Okay, let me double check. Yep, and then you get 0, 1, 2, 3, 4. Right, because remember, you take the square root. So now what we're going to do is we're going to shift it. And one nice thing about shifting this is that we don't need to find the leftmost point because it'll be found right here. Okay, so again, we have x plus 3, and then we have y plus 2. Right, so this is going to be 3, 4, 7, 12, 19. And then y plus 2, this can be 0, 3, 4, 5, and 6. Okay, so let's graph it. Right, so I have 3, 0, 4, 3, 7, 4, right? And then there's also like this 12, 5, and then 19, 6. Okay, it's out of my graph. I'm not really going to draw it. So it's going to look like roughly like this. Right, and that's our graph. Again, even taking, oh, that's why it looks so wrong. Okay, geez. This is not 0. Don't know how to add. 0 plus 2 is not 0. It is 2. Jeez. Okay, so 3, 2. Okay, this looks a lot better. Because I was like thinking, this looks super big. And it's not supposed to change the shape of the graph. Okay, because remember, these are rigid transformations. Alright, so this is our graph. Okay, of the square root of x minus 3 plus 2. So for our last example, we will do p of x is equal to the absolute value of x plus 2 minus 5. Again, what is the parent function? I'm going to label that as f of x. The parent function, the most basic one, is the absolute value of x. And what does that look like? It looks like a v. Remember, a v, very clear that there is a point at the bottom. Okay. So again, for f of x, what is the table? Or okay, before I do that, let's talk about h and k. H, okay, remember all the stuff inside. So this is going to be negative 2, and then k, it is negative 5. Okay, so what does f of x look like? F of x, the table itself. Okay, so it's 2, 1, 0, 1, 2. Alright. So we want to look at p of x. So p of x, okay, what are h's and k? So we have x minus 2, and then we have y minus 5. Alright, so again, negative 2 minus 2, that's negative 4. This is negative 3, negative 2, negative 1, 0. Okay, y minus 5, so 2 minus 5 is negative 3, 1 minus 5 is negative 4, and then this is negative 5, negative 4, and negative 3. Okay, so again, so negative 4, negative 3, negative 3, negative 4, negative 2, negative 5, negative 1, negative 4, 0, negative 3. Okay, and that is our graph. This is how you use translation. Again, just using the vertex, okay, 0, 0, right here. Okay, I can go over 2 and down 5. 1, 2, 3, 4, 5. Okay, and as you can see, that's where we get the vertex. Alright, so if you guys have any questions, feel free to email me. If not, I will see you all on Monday, and we will talk about non-rigid transformations.